Assalamualaikum warahmatullahi ta'ala wabarakatuh to Dr. Samsatun Nahar Ahmad and my fellow friends. I am ERNY JESNITA binti NIZAM as the first presenter with my teammate Khairil bin Kiran. We'll talk about the topic in chapter 2 which is quantifier. This video will be divided into 3 parts, which is the content where the quantifiers will be explained before we are going further to the 3 examples, and lastly the conclusion about this topic. So let's proceed to the introduction. Firstly, quantifier is an operator that specifies how many individuals in the domain of this course satisfy an open sentence. Open statement is a declarative sentence that contains at least one variable, while the quantification is an open sentence that can be converted into a statement. And lastly, by adding some specific phrases will produce a statement is a quantified statement. There are 2 types of quantifier, which are universal quantifier and existential quantifier. Universal quantifier is a universal quantification of Px is the statement Px for all values of x in the domain. The statement that use universal quantifier can be expressed such as for all x, for any x, for each x, and for every x. And this is the symbolic form for universal quantifier. Next, for existential quantifier. Existential quantifier is the existential quantification of Px is the proposition there exists an element x in the domain such that Px, and the other statement that use existential quantifier are for some x and for at least one x, and this is the symbolic form for existential quantifier. Next, I will show you guys the example for universal quantifier and existential quantifier. Okay, so this is the example for universal quantifier, and the question is, let Px be the statement x less than 4. What is the true value of the quantification for all x Px, where the domain consists of all positive integers? So basically, finding just one counterexample is enough to make this statement is false. So let's say we choose x equals to 5. So as P5 is false, therefore x equals to 5 is one such counterexample for the statement for all x Px. This shows that Px is not true for every x in the domain of positive integer. So we move to the example for existential quantifier, and the question is, what is the true value of for at least one x Px, where Px is the statement x squared is greater than 10 and the universe of this course consists of the positive integers not exceeding 4. So basically, our domain will be from 1, 2, 3, and 4. And we just need to find one true value is enough to make the statement is true. So let's say we choose 1. So 1 square is greater than 10 is false. 2 square is greater than 10, also false. 3 square is greater than 10, also false. But if we choose x equals to 4, 4 squared is greater than 10 is true. So we can conclude that the true value of statement for at least one x Px is true.
Okay, now I will explain further in this chapter, that is quantifier chapter. Okay, we can look at the question. So if we will understand more if we do more question. Okay, in this question state that if Z represent the set of all integers and R represent the set of all real numbers, determine the true value of the following quantified statement. Explain your answer by giving an example or counterexample. Okay, let's do this question. Okay, first question, it asks, for all x, there exists in real number that x the power of 3 is bigger than equal x the power of 2. Okay, so we can put any any example, but remember R is the represent of real number. Okay, so I substitute X with 1 over 2. So we will get 1 over 2 the power of 3 bigger than equal 1 the power of 2, 1 over 2 the power of 2. So the answer we will get is 1 over X, 1 over 8 the bigger and equal 1 over 4. So we know that 1 over 4 is bigger than 1 over 8. So this is the false statement. Okay, let's jump to the number 2 question. Okay, this question states that for at least one y, there exists in integer. For all y, there is a real number. For all x, there is a real number that y smaller than x power of 2. Okay, so this question I substitute x with 3 and y with 2. We can put any example, but as long as the term z represent the set of all integer and r represent the set of real number, is will not break. Okay, so we substitute into the equation. We will get 2 smaller than 3 the power of 2. We know that the 2 is smaller than 9. So this is a true statement. Okay, now after we learn in this nested chapter, we can conclude that in order to improve one quality of life, logic and proving are essential. They are proof that can introduce a new technique for solving other problems in mathematics or provide insight into something that isn't related to the original context. We'll be able to widen our horizon in terms of what we know and comprehend. As a result, logic and reasoning are critical to remember and apply in order to get the best or most desirable outcome.